Join me for this podcast with Denny Lee, Principal Developer Advocate at Databricks, as we discuss his involvement in Delta Lake and Iceberg, catalogs, and what's next for open table formats to enable real-time AI. Hello, everyone. Today I have with me Denny Lee from Databricks, and we are actually at the Databricks office in Mountain View.
That's right.
So thanks for the invite.
Thank you very much for coming.
To get started, my name is Dustin Nest. I probably shouldn't touch my mic. My name is Dustin Nest. I am StreamNative's technical trainer. But Denny Lee, if you want to just introduce yourself maybe for about 30 seconds, because I have a bunch of other more detailed questions about your history. So
no problem.
Real briefs, just so people know who you are.
You got it. Hi, everybody. My name is Denny Lee. I'm a principal developer advocate here at Databricks. I've been a long time contributor to Apache Spark, also to MLflow, Delta Lake, most recently Iceberg. Also Unity Catalog, and prior to that, I was actually part of the SQL Server team at Microsoft. So yeah, that's me right there.
Cool.
In 30 seconds.
So thanks for 30 seconds.
You
so for today, we're going to focus primarily, I think, and we can deviate from this, on open table formats, Iceberg, Delta Lake.
Love it. And don't forget Apache Hudi.
And Apache Hudi.
Yes.
That's actually one of my questions.
Cool. No problem.
What are all the players?
You got it.
Catalogs as well.
Yeah, absolutely.
So we're going to get into that. Those I want to focus on because that's kind of how I work at StreamNative, so that's how we interface with someone like Databricks. But you're welcome to go into other topics as well, and I'll kind of bring that up towards the end. Since we are going to focus on open table formats, Iceberg, Delta Lake, whatever you want to talk about with open formats, kind of what were your first experiences with open formats? How did this kind of get on your radar?
Oh, sure. I mean, candidly, you can even go a little bit farther back before we start talking about, because we could talk about Avro, Orc, and Parquet, right? Because those are the traditional concept of what you say is a table format. Now, obviously, they're not tables in the strictest sense, but still there are file formats in which we traditionally have these distributed frameworks like Apache Spark, like Apache Kafka, Flink, Trino, whatever else, in which they can access it so they can have table-like functionality, okay, tabular-like functionality. When we talk about lakehouse formats, the whole context behind it is that we want to provide some form of transactional protection around that data. In other words, if you do an insertion, and if that insertion fails, it's not a yes, it's not like, oh, some of the data was left behind by accident. Either the data made it into the table, or it didn't make it into the table. Those are your two options, okay? Now, obviously, I'm simplifying the concept of ACID transactions massively, but the context nevertheless stays the same, which is that you have projects like Apache Hudi, you have Apache Iceberg, and you have Delta Lake. And we all came about this particular problem in very different ways. Apache Iceberg, for example, came from Netflix. Apache Hudi came from the folks over at Uber, and Delta Lake came from us. But we are all coming from very different angles, but trying to solve the exact same thing. Providing database-like transactional protections around a file format. That's in a nutshell. Yeah.
So when where were you working when you first encountered it then? Were you already here at Databricks?
No, actually, I was starting to play with Parquet when it was contributed to Apache Spark when it was part of Microsoft, actually.
Okay.
Because I was on the team that actually introduced Apache Hadoop into Microsoft, and we built a project codenamed Isotope, which was the Hadoop on Windows. And so I was actually part of that project.
So what were you trying to overcome at that time? What was the purpose of?
So before Delta Lake, Apache Iceberg, or even Hudi came on board, we were still dealing with this problem that, okay, we agree that we're supposed to store all of our data in the Apache Parquet format. Cool. All right, that's straightforward. But then we ran into this problem where basically when you had, whether it was Hadoop or eventually Spark, where you had multiple jobs, like 20 tasks running, and they're all trying to write to the file system at the exact same time. At some point, there's going to be a failure. And so typically what we had to do is something like, okay, if it failed, clean out, or write the data to a different location, make sure that it's there, and then merge the files together. And so we constantly would do these workarounds because our jobs would fail rather regularly. Not like every single job, but you knew like after maybe 20 jobs or something like that.
When you're doing large volumes.
Exactly. By definition.
The chance you're going to hit one
very high.
Is increasing.
Yes, exactly. So then when, for example, I mean, I can talk the most from a Databricks perspective, but if you had Ryan Blue here talking about Iceberg, or you have Vinod talking about Apache Hudi, they'll provide slightly different versions of a very similar story. In the case of Delta Lake, what happened is that Michael Armbrust, he was trying to solve all these Spark problems for Apple. And so we were working with Dominic Brzezinski from Apple, and they're like, hey, we're running these hundreds of jobs every day, right? Each job would run hundreds of tasks. So of course it was failing. And so Michael was coming out thinking, hey, how do I solve this problem? So he started thinking about transactional protection around the data. And then Dom was going like, dude, I need that solution right now. So they got together back in I think it was 2017. After one of at the time it was called Spark and AI Summit. Right now it's Data and AI Summit, but at the time Spark and AI Summit. They both got together, and then boom, a few months later, Michael basically provided a early version of it, and bam, now it's what we call Delta Lake. Prior to that, it was actually project codenamed Tahoe, mainly because that's where Michael had thought of this when he was skiing at Tahoe.
So then, how did your role evolve, and how did you get to where you are in the open source community? And then eventually, we're going to want to get into Unity Catalog as well.
Oh, absolutely. No. So, long story short, when I first joined Databricks, it's just because I wasn't actually going to, honestly, I wasn't thinking specifically open source, right? I'd been already contributing to Apache Spark, but when I joined Databricks, it was back in 2015. I was there just more like, hey, this is a really cool product. And I was basically advocating for the product in my previous job.
The product being all of Databricks.
Exactly, all of Databricks. Yeah. And so then I was like, well, why don't you become an advocate for us? I'm like, cool. So I joined. Over time, I basically got involved with Delta Lake, mainly because as Michael was building it, I had actually left for personal reasons in 2016, came back in 2018, so that's actually Databricks' fault for letting me back in. So that's on them.
So was Delta Lake the back end this whole time then?
Delta Lake started being the back end around 2017-ish.
Okay. Yeah. So what was it actually before?
No. It was literally Spark jobs failing, and then we had to undo everything.
Okay.
And so it got worse and worse and worse.
Okay.
So when I returned in 2018, I think it was all 3 months when I returned. Ironically, when I returned, I was going to work on genomics and data science. Maybe 3 months into it, they're like, hey, you have a background in database systems. Yes, I do. Can you help out a little bit? Sure. And then, of course, it went from, let me help out a little bit, to becoming a contributor to the Delta Lake, becoming a maintainer of Delta Lake. So it wasn't a purposeful, we weren't thinking specifically I was supposed to become part of the open source part. It just happened.
At this point, was there a plan to open source it? Or
yes.
It was planned to open source from the beginning?
It was, no.
Or very early on?
No. Let me be candid. We originally were thinking, not as its own independent project. Okay. We were originally thinking, first of all, we were thinking, was this supposed to be, for example, the Databricks secret sauce, quote unquote?
Right. That's why I'm saying, was it a plan to...
Right. Then we realized it didn't make sense. And so we actually were thinking about, should we go open source it as part of the Spark project?
Okay.
Right. But then as we were progressing, as we're talking to more and more folks in the community, we realized, wait, this isn't just specific to Apache Spark. Like Trino, Flink, all these other projects might want to be involved too. So we don't want to limit this to just Apache Spark. So that's why we end up building our own separate open source project, specifically for, in Delta Lake, because we recognized, there are going to be lots of people who want to go do it. So if you actually go back in time, you'll notice in 2018, we announced Databricks Delta at Data AI Summit then, I think it was still Spark AI Summit then. And in 2018, we were like, based on all the feedback we got to open source the project, and we have to make it available for everybody.
So at that point then, is Iceberg even on the radar? Okay, so when was Iceberg then kind of...
roughly around the same time.
Okay.
I'll be honest, I don't remember the exact dates for Apache Iceberg Hudi. Technically, Iceberg came out roughly the same time. I want to say slightly before Delta Lake, but I don't remember the dates. I want to say Hudi was even earlier than that. But roughly in the same time frame, we're all going like, hey, we're all trying to solve this particular problem. Yeah.
So who's actually spearheading the Iceberg side then at that point?
At that point, it was definitely Ryan Blue and the crew over at Netflix.
Okay.
Yeah.
Yes, which we were at the Iceberg Summit,
Yeah.
or not Iceberg
Symposium.
Summit, the symposium.
Yeah, in the AWS Iceberg
and-
Symposium, which was the Bay Area Iceberg meetup
Yep,
in AWS back in, I want to say late January.
And then for anyone who was there, we heard a lot about Netflix and the history.
Right, exactly, yeah. So really interesting, right? So like I said, typically, what people often say is like, oh, you guys are competing. We're like, well, in some ways, yes, but the reality is that we were just coming from very different angles on how to solve the exact same problem.
Yep.
So.
And at that point then, we're talking 2017, 2018?
Oh, 2019 is roughly when we
Okay.
actually open sourced it, though.
Okay. So where are catalogs at that time?
Okay, depending on who you ask and how the answer is. Okay, as a general statement, catalogs were, technically they're still in infancy now, but they were definitely in their infancy then. To some people, catalogs were an important, crucial aspect. So I'll definitely say Iceberg in comparison was much more catalog friendly. In comparison, Delta Lake was not as catalog friendly. It doesn't mean you couldn't use it, just it was. The long story short, Iceberg came in because they were thinking like to work with the Hive Metastore catalog, right? And in our case, Delta Lake, we were going out of our way to not use a catalog because we knew, due to the huge size of Apple, for example, we literally the catalog couldn't handle it. We would break it. And so now, since then, catalogs, the technology behind it has advanced massively. So yeah, now we're very comfortable with
the catalog's a metadata store, basically.
Exactly, that's all
So
it is.
at that point, you need. We, as our backend, we used to use Zookeeper.
Right.
And then we moved on to Oxia. Is that
Yeah.
the same type of issue where Zookeeper is a single node and it can't hold all the data? And
Well,
Oxia
okay,
is
so
distributed?
Zookeeper is more like is almost like more like closer to like a consensus algorithm, right? Think Paxos, right? Think Raft, right? Where it's just basically you've got multiple tasks that have to decide. We have to decide which of those tasks are if they say, like, for example, this file has been written. Which one actually, and another task is saying, no, it hasn't, which one do you choose? It's a consensus algorithm to decide what actually had happened, right? In the case of Spark, we switched over from Zookeeper to the Akka/Actor framework, which itself is embedded in the Spark, and a lot of the other distributed frameworks did something very similar, okay? So that's why we're no longer sort of Zookeeper-centric. Now, in the case of the Metastore, somebody has to tell the Metastore, for example, in the case of Iceberg, what's the exact schema of the table, and maybe some statistics, let's just say. And at the time, that's what Iceberg did. And at the time, Delta Lake was going like, no, we're not going to be dependent on the Metastore. The Metastore is actually in the transaction log of the Delta table itself. And so all the Hive Metastore had was basically a pointer. It just simply said, here is where the metadata is. That's it. And then you would be redirected to the metadata that's sitting in the file system. Okay? That's the real big differences between like the way Iceberg did it and the way Delta Lake did it.
Okay.
But as things have progressed, you're going to see more and more of, like, whether you're talking about Unity Catalog, one of our open source projects, or Apache Polaris, or the umpteen other very cool catalogs that are out there. The reality is more and more of that metadata gets placed inside a trustworthy database. I'm putting in quotes.
A source of truth, almost like.
Right, exactly, because it can be a database, it can be something else, but it's a source of truth, right? That we can all point to, that's just transactionally consistent, so that way we can be sure that the metadata is safe. That tells us, okay, here is where the table is, here's the columns that are in there, here's some statistics to help you query the data, because that way you can say...
Like where ranges are and time
right,
ranges
exactly,
and things like that.
exactly. In other words, you can say, okay, if you want data from this particular date range, you can just hit the metadata
So that's
first.
that's all in the catalog.
Some.
Okay.
Some is in catalog, some is not, depending on which project.
Okay.
Yeah. I mean, we're all going more or less in that same direction, which is like sometimes we don't want that data in the catalog because it slows things down, but sometimes it does make sense to put that metadata in the catalog because it speeds things up. It's that really interesting
It's all about
balance.
optimizing.
Right, very much so. So we're all progressing the same way, like it's just from slightly different angles, that's all, yeah.
So we went through a little bit of the history. Can we kind of get to what is state of the art? Where are you at right now with open catalog or open table formats and catalogs?
Okay.
What is the current state?
No problem. So open table formats themselves, really, it is Iceberg, it is Delta Lake, it is Hootie. Okay. My usual response to almost everybody is this. Obviously, I'm personally biased toward Delta Lake because I'm a Delta Lake maintainer. Okay. But the reality is, I don't actually care which one you use. I just carry that you use one of them. Okay, and the reason I carry you use an open lakehouse is because this is setting across the context of there are many proprietary systems out there. And so that means your data is locked in. At least if you have an open lakehouse, again, whether it's Hootie, whether it's Iceberg, whether it's Delta Lake, at least it's an open format, and that means you can move the data as you see fit.
Well, that's what I like to hear too, because that's the way our software is progressing.
Exactly.
Which I'll talk about in a little bit.
Absolutely, right. So that's the context. Like so we are like whether you're talking about Apache Hootie with, for example, their Xtable project, whether you talk about Delta Uniform, whether you talk about the integrations of, I want to say 0.14 of Iceberg, where they actually can go the other way, which is like to basically, it's not uniform, but I forgot the name of the feature, but basically Iceberg table that looks like a Delta table, right?
And if you want to explain what is uniform for anyone who doesn't know.
Oh, sure. I'm sorry. Delta Uniform is the ability to basically generate the Iceberg metadata or the Hootie metadata from a Delta table. So in other words, you have your Delta table, it has the Delta metadata, but at the same time we generate the Iceberg metadata and we generate the Hootie metadata, so then boom, you're good to go. And Delta Lake 3.1 for Iceberg, Delta Lake 3.2 for Hootie. And so it doesn't matter. Like as we progress, we're going to see more similarities between these projects. Like for example, a small example is, for example, deletion vectors. Iceberg introduced, as part of their V3 specification, their version of deletion vectors. It uses roaring bitmaps and the Puffin format. We won't dive into it now, but if you ever want to go into it, you could have just watched the video from the Iceberg symposium that we were at, and where Anton dove right into all that stuff. But the reason I'm bringing up this context is that it's actually completely compatible to the Delta Lake deletion vector. Right, so even though it's built differently, we're compatible with each other, and I'm seeing us progress like that, where basically the communities themselves were already starting to go closer to each other anyways, recognizing what worked and what didn't work. Perfect. Well, then we'll continue doing that, and we'll work with the communities, both the Delta Lake and Iceberg. Those are the ones that I'm more involved with, to basically make sure that interop is the number one thing. So that way, it doesn't matter you chose Iceberg, doesn't matter you chose Delta Lake. For that matter, it doesn't matter you chose Hootie. It's okay. It was right. It was the right choice. We're going to make sure interop, and then boom. So then it goes to what is the bleeding edge. If we no longer debating about, like what I want to see is that we're no longer debating about the open lakehouse formats, because it's one of the three and we're done. Okay. So the analogy I often use is like, okay, do you really care whether it's UPS or FedEx or DHL? No, you just want it done. Perfect. That's all that's happening here. So that way the focus is on the catalog. The thing about the catalog is that we're still in its infancy, so we don't know where we're at. But I think an important aspect is that a lot of us are very much clear on the idea that we're going to go IRC, the Iceberg REST catalog specification. So in other words, whether it's Unicatalog, Apache Polaris, Gravantino, Data Strato, whatever, I don't care. Like there's a lot of really good catalogs out there. So this isn't like me trying to choose one or the other. This is just saying, look, there shouldn't be a war here. There should be one standard. We all follow that standard, so that way nobody, whether it's us or anybody else, is locking your metadata in. Like, because really, the metadata is the secret sauce to your data. Do you want somebody to control that? No, you don't, right? So if we're all following IRC, it gives you maximum portability, so then the real value isn't that you have a catalog. The real value is, can you actually make that catalog much more powerful, or the value adds on top of it so that it helps you with your business? If we weren't doing a podcast, I'd show you, for example, the data lineage feature in Unicatalog as an example, right? And it allows you to basically track all the different sources of tables all the way down for both the tables, whether they're downstream, whether they're upstream, so that way you know if you're about to make a change to the table, what systems you're about to impact. That's really powerful stuff, right? That's a good value add. That's what I want to see. I want us to see us not debating with each other on what the catalog specification is. I want us to start debating on how do we make this easier for everybody, whether you're a data analyst, whether you're a data scientist, whether you're a data engineer, or you're just a VP. Not to insult VPs on this channel, but who just wants to see what their data is doing, right? They don't have to have this massive technical acumen to be able to say, okay, which table I'm supposed to hit in order to query this data. No, that should be available and easily, and also with the necessary authentication and authorization. So obviously the VP is allowed seeing it, but me, am I allowed looking at the HR data? No, I'm not allowed looking at that, and nor should I ever. So simplified authentication authorization to ensure that only the people who have rights to that data get access to that.
I also want to kind of go into just a little bit, what kind of data actually can you store in the catalog then, or reference from the catalog? So I work with one very specific type of data.
Sure.
That's going to be like a write-ahead log where you're writing massive amounts of data.
Yeah.
But and they're in data streams, and you can access it as a stream.
Yeah.
But I think you can also store all of your data about your models and their version history.
Right, exactly. So, for example, typically when we talk about the IRC or table specification, we're typically talking about like your tables, the columns, who has authorization rights to it, yada yada yada. Okay.
Yeah. And when you query massive data sets, that's the kind of stuff I work with, where you're like, I want these ranges, but there's other types of data.
Exactly.
So the catalog actually becomes a much larger.
Exactly. So, for example, Unity Catalog, which we believe as Databricks that this is where we all should be going to, is that the same authorization, authentication, the same data lineage, the same context of how you access the table and the associated streams should be also how you access volumes, or how you access functions, or how you access models. So in Unity Catalog, you actually can handle all of these things. So what do you mean by volumes? Well, basically the idea is like, okay, I'm storing data that isn't necessarily tabular format. Maybe I'm storing images, maybe I'm storing music, whatever else. But there are these sets of data, maybe not in tabular format, that also require the same authorization or authentication context, or same lineage context. So, boom, that's what volumes are for. Functions, maybe there's some business logic, right, that you actually have created that some people are allowed accessing, some people are not allowed accessing, but you want to be able to apply that to multiple tables. So for the folks that are allowed accessing those functions, they can use the exact same function. Let's just say it's calculation of some sales metric, right? You want to be able to apply that to everything, any table all throughout. Any table that exists in the system, you want to be able to apply that function throughout. Or maybe it's a function which calls a large language model to do that specific to your own instantiation of an agent that specifically gives you domain-specific answers, right? You want that function to be very specific to only the right people that are allowed accessing that, but you want to use the exact same logic for the people who are allowed doing it. So that's why functions are always are involved. And then finally, models. You've got machine learning models, you've got large language models, you've got AI models in general. Similar principle. There are going to be people who have the rights to it. You want to know what the lineage is, you want to keep versions of it, you want to be able to have a repository that says here are the base or the golden models that we're going to go work with, right? So where we, at least from our perspective, feels that this is where the real power of having one catalog handle all these things, because the authorization authentication context, the context around what lineage, what sources are going in and going out, it really is one thing, right? You as a user, doesn't matter if you're, again, business analyst, VP, data engineer, data science, we all should be agreeing on these simple rules. So having the catalog handle that for you allows you to control that business context so much better, and you can templatize it. And that's why, like, this is where we see it going, right? And we'll see what happens. That's why we open source UC, because we recognize so many people are going like, but we want to add this. Oh, can we add this? And we're like, cool.
And if they don't want to use that component or that one feature, they don't have to.
Exactly.
But it's there so that you can put everything together.
Right. And invariably, that's what happened to Unity Catalog, which is that basically we started with tables and it just blew up because we recognized
what was working. Yes. So then they're like, let's do more things
more. Exactly. Yeah, they love that context, and we're like, okay, cool. Yeah. And so we're pretty happy with the project, as you can tell. Yep. And then again, similar concept. There's an outpouring that's saying, hey, we need to open source it. We're like, cool, and we did.
Cool.
Yeah.
I want to bring up one topic related to batching and streaming.
Sure. And
how well open table formats work with that. And before you get into it, obviously I bring it up for a very specific reason, because Stream Native has our Ursa engine, which is Kafka compatible, where we can take Kafka data into our engine, and it actually stores the data directly into object storage, then compacts it down into Parquet files. And we're compatible with doing that into Delta Lake or Iceberg, or working with multiple different vendors with their catalogs. But the goal really here is to find a very cost-effective way to move large amounts of data through a streaming engine so you can enable real-time AI.
Gotcha.
So that is our goal. And we want to hear your opinion then on what's going on with Iceberg in that more real-time format and how that enables AI.
Oh, no problem. So I'll actually give you the context from both Delta Lake and Iceberg. Okay, so Delta Lake itself, the reason, for example, the Delta Lake metadata is very linear. Okay, it doesn't have any hierarchies. The whole reason why is because we needed the optimal writes, right, in order to be able to go ahead and handle the fact that we're talking milliseconds data is coming in, so you have to keep state. So how do you do it? Right? In the case of Iceberg, the issue at hand typically was that because you have to build a hierarchy, it technically slows things down. But saying all that, Iceberg community is working long and hard to basically get Iceberg to a point where it can actually handle streaming extremely fast. Okay, but the reality is
the limitation if when you stream, you're going to start with very small Parquet files, and you need to commit very, very frequently.
Exactly.
That's the limitation.
That's the limitation.
And then later on, you can always go through another compaction process of then taking many Parquet files and making them small, or one large one.
One large one.
But the goal, you're really limited by how quickly you can make a whole bunch of small Parquet files.
Exactly. Which in the end, the real solution, and that's why solutions like yours exist, okay, is that you're actually going to try to do as much of that in memory first, because that's where you're going to actually have the lowest latency to begin with, right? And because it's storing in memory, and then you have some async or sync process, depending on how you want to structure it, that writes it down. And so from that point onwards, whether it's Delta Lake or Iceberg, doesn't really matter, honest to God, right? Well, the real question is, whatever you are using for your processing engine, in the case of StreamNative, for example, how are you actually ensuring that you're keeping state in memory long enough for whatever process to exist to get it down into a stateful lakehouse format storage?
Yes.
Right? That's it. That's what it boils down to. And so as we, as a community, make the Parquet files, the metadata run faster, irrelevant of how we do it, in that'll help. But the reality is, as people are running streaming more and more and more, whether you're talking about Kafka, we're talking about StreamNative, talking about Pulsar, you're talking about structured streaming, doesn't really matter. What matters is that more and more of the stuff has to be done in memory, and more of it has to have some form of checkpoint to ensure that state isn't lost.
Yep.
And that's always a hard problem.
So we actually can't wait for the Parquet file to be made.
Exactly.
Because we are under an obligation to respond to the producer as quickly as you possibly can.
Right.
So we have to write in a non-Parquet format first.
Yeah,
which
agreed.
which we're calling the URSA format right now.
Yeah.
And then eventually you would convert that into a Parquet file. And that process of how frequently you convert to a Parquet file and then commit is tunable by our engineering team.
Right.
Because some people may want to just wait 30 seconds or something like that potentially and make that Parquet file, or they might say I only need a second or a few seconds.
Right. And so if you look at, for example, Flink, they have their own format for exactly that reason. If you look at Project Lightspeed from Structured Streaming, they're doing something very similar as well. We're all going down the same path of recognizing we can't have the time to write to a column or format.
Yes.
In the time frame that's required for the producers to be able to react.
But what we're saying is we do have enough time to wait for object storage. So we're not going to an expensive dedicated disk first.
Right.
And then going into Parquet, we're going into object storage in an unsorted manner.
Right.
And then sort it into a Parquet file.
Yeah, makes sense.
Yeah.
So ultimately, what it comes down to is that we're all going very similar directions when it comes to streaming, which is the fact is that you actually have to react to it fast. And so whether that is exactly like the URSA file format that you're talking about, whether it's the other mechanisms that Flink does or structured streaming does, or other systems altogether, where, for example, they decide to put it in like an Alluxio type setup, which is in memory, in memory, quote unquote, file system, right? In the end, exactly to your point, we have to have something that's fast enough to keep that state so you can react to the producer. It's as simple as that. Yeah. And we'll never get Parquet And by the way, the reason I like calling this point out is because a lot of people are trying to treat like lakehouse formats as OLTP formats, like transactional formats. And that's what streaming is. Streaming is basically really, really fast transactions. And so my response is like, no, all the lakehouse formats were designed for OLAP, online analytical processing. We provide a transactional protection, but around analytics, not around OLTP. Now we're getting to a point where people are recognizing, oh, OLTP is important, and I need just more than a PostgreSQL database. Don't get me wrong, Postgres is awesome. I will never insult it, so this is not me knocking it. But there are definitely more and more scenarios, especially with the volume that your company and my company typically sees, that Postgres is not enough for all of those scenarios. And so, boom, we're all trying to solve these type of problems.
And just to be clear, that kind of the trade-offs that we deal with then are, for us, it's latency to acknowledge to the producer.
Yeah.
If you can't relax your latency,
right.
This method of writing directly to object storage as that first write is not going to be good enough for you.
Exactly.
You need to go to disk, and then you would potentially maybe go to Parquet. So you're talking about latency and cost.
Right.
In all of this.
Absolutely. Yeah. It really is based on your business scenario. Your business scenario. And to your point exactly, there are more and more business scenarios that require what you guys are doing right now.
Exactly. I mean, that's why we're doing what we're doing.
Yeah. Exactly. Yeah.
And the type of data, the large volumes of data that need to get into these open table formats cheaply is increasing as you guys are doing more AI on it. So,
oh my goodness.
So we're here to help get that data cheaply into the open format.
Oh, absolutely.
As quickly as possible. So let's talk about what's coming next.
Sure. Always will.
What's going on if you want to talk about open table formats and catalogs? What are you guys working on?
Well, I mean, open table formats, the reality is we're, from a Delta Lake perspective, we're working on a lot of our focus is actually on the Delta kernel side. And the reason we're doing a lot on Delta kernel is that we're trying to abstract away the metadata reading. So that way when you're Flink, when you're Kafka, when you're Trino, when you're Spark, when you're Rust language, doesn't matter. When you're accessing Delta Lake, you no longer actually have to understand how to access the metadata. We just abstract the whole process away from you. And so that's what the Delta kernel project is. We have one that's meant for the Java side and one that's meant for the Rust side. And so,
does that mean new APIs and SDKs, or what does that mean?
New SDKs. APIs are going to be very, very similar. So we're trying to abstract it as enough of a way so like whatever you did before stays the same. But by the same token, integrating, especially because we keep on adding new things like like change data feed, deletion vectors, things like that way, that you can. Your systems doesn't actually have to understand change data feed to actually use change data feed, as an example, right? Iceberg is currently going through the V3 specification right now. There's a laundry list that I'm going to completely forget right now, honestly, of all the things that are within V3, but it's also advancing things like deletion vectors, the basis for Iceberg's version of change data feed. And so we're working very closely with the Iceberg community on how that's going to shape up as well. When it comes to catalogs, IRC, Iceberg REST catalog, unequivocally. We feel that seems like most people agree that we should all just go with the Iceberg REST catalog specification, and we're going, cool, then let's
So are you saying Unity catalog, basically you'll just query it with Iceberg REST catalog?
Well, it already can.
Okay.
It already can.
Okay.
Yeah. No, it already can. No, what I'm implying strongly is at some point IRC will be the standard and UC's own APIs are going to go away. That's what I'm saying, okay?
The backend will still be Unity catalog.
Oh, yeah.
But you're just going to have a same interface, basically.
Yeah. Whether it's Polaris, whether it's anybody else. And the whole reason why is because we're like, no, we don't want you all to think about it. That's it. Hit it one way, whether it's us, somebody else, don't care. I just don't care. Because the best way I can sort of explain is like, we inadvertently got into a table format war, right? That's what between Iceberg and Delta, and it's not really a war because while other companies were trying to make a big deal about it, we all know each other from Apache Spark. A lot of us come from Apache Spark to begin with, so we're like, we're all friends. There's not really much of a war here, okay, guys? But basically, where we're coming from is like, okay, cool. Well, we're all working together on Delta Lake. We're all working together on Iceberg. Cool. All right, take that lesson. Let's continue all working together with IRC. So in other words, we don't want a catalog or we're not interested. We want us to actually focus on providing everybody open standards for everything So that way we're competing on what we should be competing on, which is the value on top of it.
Okay.
Not locking people in.
And as you said, Delta Lake isn't the secret sauce. All that value on top is the secret sauce. So
right. Iceberg's not the secret sauce. It's the value on top. Polaris or Unity Catalog isn't the secret sauce. It's the value on top. That's what we should be competing with each other on. And that's where a lot of us are coming from, because the whole idea of us saying like, oh yeah, we want a catalog war. I'm like, cool, we don't.
Because, they're going to use you for your system, the overall system, and whatever catalog you have, basically you're going to guarantee that it supports the system that you're building on top.
Exactly.
And if the catalog becomes a hindrance, you'll find a solution. You'll adopt whatever solution you need.
Because in the end, that's what people are like, oh, you're not going to work with other systems. Like, no, that's the whole reason we have federation. The whole premise is for us to be able to work with other systems too. No, so we have to have a standard we all agree on. Like I said, the community is more or less pushing toward IRC. We're like, cool, then let's do it. Done. Next problem.
Yep. we'll take that.
Yeah, we'll take it. Go.
Fine.
Yeah.
So where are we at then with the biggest challenges? What's left?
The challenges are always like, how do we? Okay, like any other open source project, what are we going to agree on the specifications? Okay, and there's this challenge between when you're trying to go really fast to provide value to your customers, while also ensuring an open standard so there's portability and flexibility. That's the real challenge.
Which slows down because you have to get community agreement.
Right.
But you're like, I need a product release for our secret sauce.
So
for a month from now.
Exactly. So what people often understand is like, it's like, yeah, but this open source stuff's messy. Like, of course it is. Like, that's actually, if there's a secret sauce to open source, that's actually it. And the people are like, wait, why? I'm like, because that's the whole purpose. We're actually having discussions. Company X is going to try something. Company Y is going to try something. We're going to agree, hey, that's a great idea. Or no, that was a dumb idea. Whatever.
You get the learning out of that.
We all get learnings from that, and then we improve the specification together. That's the whole point. So in the end, my take on this whole thing is like, look, people think it's messy and they're trying to avoid the mess. And my literal response is like, no. The mess is the reason why we get things right. So either you participate with the community so we can get it right, or you don't, and then we're going to get it wrong. So what's the challenge? We're going to keep on working together. We're going to figure it out, and we're going to have to find the balance between, sometimes we're going to go, not just us, anybody will go ahead because they're trying to push a feature in or push an idea in. Sometimes it'll work great, sometimes it'll work horribly. That's fine. Versus, or with the idea that, oh, we have a specification that we all agreed to.
Yep.
Yeah, that's a challenge, and it's a great challenge to have.
Any limitations you see coming as as we kind of wrap up?
Yeah.
Any limitations you see in the open table formats? Any where you think there might have to be another paradigm? We obviously like object store, and we like this transaction, but are the secret sauce that you're building on top, is it eventually, do you see any limitations to using that?
Oh, absolutely. Because the reality is, like, one thing that we've been talking about, but we haven't explicitly stated, okay, is that remember I said OLAP, OLAP, Online Analytical Processing, and the other major system is online transactional processing, OLTP. And then the reality is, when you talk about streaming in real time, that's even faster than OLTP anyways. Can we have, forsake Urban, one format that can handle all of that? Can we, forsake Urban, have one catalog that can handle all that? Honest to God, I don't know. Like, I really don't know. I mean, we obviously are going that direction, but are we actually solving it? I don't know.
Is that what will be needed for actual real-time AI? Or
yes, and this is the reason why. So, for example, one cool project I love working with them on is LanceDB, right? They've brought up a very, very interesting format that's designed for multimodal AI. Now, I don't think that's the one and only, by the way. I think there are many other really interesting ideas. But I see that as we recognize how, for example, when it comes to, forget about even multimodal, just AI in general, everything up to the point that you and I have been talking about when it comes to streaming or even transactional processing, and to an extent even analytic processing, it's serialized I/O. The problem, unequivocally, when it comes to OLTP and unequivocally the AI, it's randomized I/O. In other words, you're hitting the disk all over the place, or hitting the object store all over the place. How can you make that efficient? Okay? How can you build a file format or a metadata format or in-memory format, whatever format, can you actually handle that? And that's where the trick really is. That's where the trick lies. And I do see that as more and more people start building AI systems, we're going to need to see that. Now, can we solve that with a database? Maybe. Do we need something else? Maybe. We don't know yet. We're still working that out.
Any final notes you want to make to our listeners?
No, really appreciate you coming by and coming to the Databricks Mountain View office for us to have this wonderful chat.
Yep.
I know, lots of fun, and we'll keep on rocking at this stuff.
Yes, absolutely. Thanks for the invitation. It's been super exciting to work with open table formats, and we'll be talking again soon, I'm sure. So thank you so much.
Perfect. Thank you.